So for now, we're moving away from simplifying roots to estimating roots, in this case to between two consecutive whole numbers. With part A, we have the square root of 38. So again, we're looking at what perfect squares are close to 38, the value that's under the radical. So if we look at 6 being squared, that equals 36, which is less than 38. And 7 squared equals 49, which is greater than 38. So we know that 6 is less than the square root of 38, and that the square root of 38 is less than 7. And we could also say that since 36 is closer to 38 than 49 is, that the square root of 38 is closer to 6 than it is to 7. With part B, we're looking at cube roots. We might not have these memorized to the point where we know where we are, comparative to where we are with square roots and perfect squares. Cube roots and perfect cubes we're probably not as familiar with at this point. So it might take a little bit of trial and error. Now that said, if we look at 4 cubed, that equals 4 times 4 times 4, which equals 64, which is less than 93. And 5 cubed, that equals 5 times 5 times 5, which equals 125, which is greater than 93. And again, that tells us that 4 is less than the cube root of 93, which is less than 5. And again, that's because 4 cubed is 64, which is less than 93. 5 cubed is 125. So these are the two closest perfect cubes, 64 and 125, to the cube root of 93. Or the perfect cubes that are closest to 93, so their cube roots are the closest to the cube root of 93. So in other words, this is because 4 cubed is less than 93, which is less than 5 cubed. Or in other words, 64 is less than 93, which is less than 125. And if we wanted to see which one it was closer to, we would just subtract 93 from each one of these, or find the difference between 93 and each value to see which whole number that it's closest to. But to the nearest two consecutive whole numbers, the cube root of 93 is between 4 and 5, and as we just showed before that, the square root of 38 is between 6 and 7.